Hi everybody. Today we are going to discuss another important session in physics, electromagnetic induction. So we are starting with a small story. You know, the scientist Michael Faraday, once he is demonstrating his experiment in a seminar, he is showing that there is a wire that is connected to a galvanometer, and there is a coil and a magnet, and he is moving the magnet towards the coil. The galvanometer deflects. When the galvanometer deflects, everyone clapped. Then without the battery, there is current. But in the audience, there is a lady. She stand up and asked to Faraday, what is the use of this experiment? Then that lady is carrying a small baby in her hand. Then Faraday replied, what is the use of this newborn baby? And then she said, it is my baby. So he said that is the use of this electromagnetic induction. So it's a wonderful topic, electromagnetic induction. And you know, electromagnetic induction is nowadays everywhere we are using. Transformer, we cannot think a day without having transformer. We cannot think a day without having generator. So all the facilities, even in our mobile, everywhere, wherever the electricity and magnetism are utilizing in the world, everywhere this topic is important, that is electromagnetic induction. So today we are going to discuss electromagnetic induction, important MCQs. You know, electromagnetic induction is a very important chapter in our syllabus. We are discussing first the NEET questions and last year board questions and the most probable questions one by one. When I am saying today the discussion will be little lengthy, numerical will be there. Don't get bored, because we have after 20 days our board exam is coming. A question will be a window to solve many other questions. So each question when I am explaining here, attend the session correctly and you can ask doubts in that and you can clear it. Now we are going to start the questions now. So please see what is the first question. You know, the first question is about self-inductance. It's the first question because 2022 CBSE Term 1 exam, this question came. What is that question? The self-inductance of a solenoid of 600 turns is 108 mH is there. mH is millihenry. The self-inductance of a coil having 500 turns with the same length, same radius and same medium will be. So we know how to find the self-inductance. The formula for self-inductance that we can say, self-inductance is equal to mu naught n square if you are considering A divided by L. So this is the equation for self-inductance. We are considering this equation. Now they said in the question that is same radius is there, same length and same radius and same medium. So radius same, so area will be same. And we can say same length, so length will be same, and we can say same medium, so that is clear. We can say that correctly here, the medium, area and length same. So L depends only on n square now, so we can say that is L directly proportional to n square. So we can take here the formula, that is L1 divided by L2 is equal to n1 square divided by n2 square is there. Now we are substituting the values. So we can say L1 value is 108 millihenry. So 108 divided by L2 is equal to n1 square. You know, see first term it is 600. So 600 square divided by N2 square. N2 is equal to 500. So 500 square is there. So simplifying, you will get the L2 value. So here I am cancelling now. This is 6 square divided by 5 square is there. So that is equal to 36 divided by 25. So L2 is equal to 108 into 25 divided by 36 is the equation for L2. Simplifying 108 divided by 36, you can simplify that and you will get the answer that is equal to 90 millihenry is there. So the right option is correctly, see that we are simplifying and you will get the self-inductance correctly in this question. So this is the first point that we are taking. Self-inductance is directly proportional to square of the number of turns. L1 by L2 is equal to N1 square divided by N2 square is there. Now we are explaining the next question. So the next question is, a constant current I is maintained in a solenoid. Which of the following quantities will not increase if an iron rod is inserted in the solenoid along its axis? So please see, when we are inserting an iron rod into the coil, then how the self-inductance will change? That's the question there. We know the point. There is a solenoid. So we are considering there is a solenoid. And we are inserting an iron rod into the solenoid. So iron rod is inserting into the solenoid. So what are the change will be there? So first of all, about magnetic field. The magnetic field B is equal to mu naught Ni. That's the equation for magnetic field. When the medium changes, we can say the new magnetic field is equal to mu naught mu R Ni will be there. So definitely magnetic field will change. So magnetic field will change because the medium is changing. Now they are asking about magnetic flux linked with the solenoid. What is the equation for magnetic flux? Magnetic flux phi is equal to BA cos theta. Flux phi BA cos theta. Magnetic field changes. So of course magnetic flux will change. So we can say magnetic flux also will change. Now self-inductance of the solenoid. What is the equation for self-inductance? We studied phi is equal to Li. So we can say L is equal to phi over I is there. So we can say that correctly, L equal to phi over I. The flux changes, so definitely self-inductance also will change. So the three definitely changing. Field changes, flux changes, self-inductance changes. And then they are asking, what about the rate of joule of heating? The formula for heating, that is H is equal to joule heating. It is I square RT. When we are introducing a material into the coil, there is no change in resistance, because resistance depends upon nature of the material only. In which medium, that is not depends. So we can say current is also not affected. So rate of joule of heating is not affected. So right answer is option D. So the second question, the right answer is option D. Now we are explaining question 3. Look, question 3 is also the 2022 CBSE question. They are giving a coil of area 100 centimeter square. A coil of area 100 centimeter square is kept at an angle of 30 degree with a magnetic field of 10 raised to minus 1 Tesla. So look, they are giving the data. Then the magnetic field reduced to 0 in 10 raised to minus 4 second the induced EMF in the coil. So we have to find the induced EMF. What are the datas given? We can say area equal to 100 centimeter square. You know, 100 centimeter square, that is 100 into centimeter means 10 raised to minus 2 meter whole square. So that is 100 into 10 raised to minus 4 meter square is area. And they're asking angle is given. So what is the angle? Theta is equal to 30 degree. Angle given. Magnetic field is given. So now magnetic field is given. That is equal to 10 raised to minus 1 Tesla. They're asking what is the induced EMF in the coil? What is the equation for induced EMF? Induced EMF, we know the equation E equal to minus d phi by dt is the formula for induced EMF, where phi is flux. So I can write that is minus d by dt of BA cos theta. BA cos theta. Here area is not changing, angle is not changing, but the magnetic field is changing because they are saying it is reduced to 0 and the time interval is also given. So I can take that is area outside and then cos theta outside, then it is dB by dt is there. So all values we can substitute. So we are substituting the values for area. So area is 100 into 10 raised to minus 4. So minus 100 into 10 raised to minus 4. And cos theta, angle is given, that is equal to cos 30. And then we need dB by dt. dB means change in magnetic field. Change in magnetic field means it is the final field minus initial field. So what is the final field? 0. And initial field is already given, that is 10 raised to minus 1. So I can take 0 minus 10 raised to minus 1 divided by the time interval is given, that is 10 raised to minus 4. 10 raised to minus 4. So simplifying the data here, so we can say here in this question 10 raised to minus 4 and 10 raised to minus 4 cancelled. Now here we have a minus 100 into 10 raised to minus 1. So it's coming, that is equal to 10 will be there. Minus of minus, so it becomes the 10. Cos 30 is root 3 divided by 2. And 10 by 2 is 5. So the answer will be 5 root 3 volt. So the right answer is actually option A. 5 root 3 volt is the right answer is coming. Yes, Rudra, right answer correctly, Reshma, right? So the answer is correct. That is 5 root 3 volt is the answer for question 3. So it's very important when we are reading the question. I'm repeating once more. When we are reading the question, check whatever it is changing. In order to produce induced EMF, there are 3 methods. Either you can change area, or you can change field, or you can change orientation. I'm repeating once more, which are the 3 methods to change or to induce EMF in a coil. Change the field, change the area, or change the orientation. Now we are going to the next question. So that is question 4. A square loop of side 1 meter and resistance 1 ohm is placed in a magnetic field of 0.5 Tesla. If the plane of the loop is perpendicular to the direction of the magnetic field, the magnetic flux through the loop is 2022 NEET question it is. So please see, look, a square loop of side 1 meter. So length given, that is 1 meter here correctly. So we can say the length is given, that is 1 meter. Length is 1 meter. And resistance R equal to 1 ohm. R is 1 ohm and magnetic field 0.5 Tesla. And one more, the plane of the loop is perpendicular to the direction of the field. So this point is very important. Plane of the loop is perpendicular to the direction of the magnetic field. You know, what does it mean? They are asking magnetic flux. So what is the equation for magnetic flux? You know, magnetic flux formula phi is equal to BA cos theta is there. So what is theta? Angle between area vector and magnetic field. Theta is angle between area vector and magnetic field. So here, how we can find that angle now? So suppose this is the square loop. You know, area vector is always normal to the plane of the coil. So suppose I am considering this is the area. My palm is the area. So its area vector will be like this now. So area vector will be outward, directed normally outward. So we can say here area vector is a marking as 3 dimension is not possible. I am marking this is the area vector. Now in this area vector, they are saying in the question, field is also perpendicular. So we can say the magnetic field is perpendicular, loop is perpendicular to the direction of the magnetic field. So I can mark a magnetic field is also perpendicular to the plane of the coil. So A and B are in the same direction. In my experience for the last 15 years, most of the students are making error in the calculation of flux. What's the problem? They think perpendicular theta 90. Repeating once more, please take care. Perpendicular means it is not the angle between plane and field. It is the angle between area vector and field. You know, area vector is normally outward. So field is also perpendicular means area vector and field are in the same direction. So we can say the angle is coming 0 there. So phi is equal to BA cos theta. Magnetic field we have to find here. Magnetic field is given 0.5 and then area, it's a square loop. So we can say that is equal to 1 square and then cos 0 is coming. So cos 0 is 1. So we are getting 0.5 Weber. You know, Weber is the SI unit of magnetic flux. I'm repeating once more as we have only 20 days. Please see, if the plane is perpendicular to the field, theta will be 0. If the plane is parallel to the field, theta will be 90. So we have the formula 0.5 Weber. So the right answer is option B in this question. Now we are explaining. Yes, Adil Rafiq. Now we are going to the next question now, question 5. Question 5 is a very important question that we are explaining. 2021 NEET question. A big circular coil of 1000 turns and average radius 10 meter is rotating about its horizontal diameter at 2 radian second inverse 1. If the vertical component of the earth magnetic field at the place is 2 into 10 raised to minus 5 Tesla and electrical resistance of the coil is 12.56 ohm, then the maximum induced current in the coil will be. Dear, we know when a coil is rotating in a magnetic field, it will experience an EMF. From where we studied that there at the end of the chapter EMI, we have AC generator. In AC generator, we studied there is an armature coil. Armature coil is rotating. When armature coil is rotating, an EMF will be induced in the armature coil. You know, what is that induced EMF equation? we studied the induced EMF induced in an armature coil is NAB omega sin omega t. That is the induced EMF in an armature coil. But they are asking in this question, what is the maximum induced current? So if current is maximum, EMF will be maximum. So we have to find the maximum induced EMF. So what is the maximum induced EMF? If omega t is equal to pi by 2, we know that is sin pi by 2 is 1. Then we are getting the maximum value. So the maximum induced EMF is equal to NAB omega. If you have a maximum induced EMF, you can find the maximum current. Maximum current I max is equal to the maximum induced EMF divided by resistance, E max divided by R. So the formula for EMF NAB omega divided by R. So each term we can substitute there. So first of all, 1000 turns. So N is equal to 1000. And here average radius is 10 meter. So area pi r square. So I can take pi into 10 square is the radius. Then magnetic field is there. 2 into 10 raised to minus 5. Omega is radian per second. Everyone knows that. So we can say omega 2 radian per second divided by the resistance. Resistance is, we can say 12.56 is there. Now see, we can simplify. Suppose we are considering this picture now correctly. Look, see, suppose I am taking the idea now here. Look, here pi is there and 2 and 2. So 4 pi. Look, 4 pi is 12.56. So they cancels each other. So these terms are cancelling. So what's the remaining term now here? So when we are considering the remaining terms here, that is here 1000 is there and 10 square is there and 10 raised to minus 5 is there. So the answer is 1 ampere is the right answer. So we can say option C, the right answer. Yes, correct. C is the right option. So we can say the maximum current is 1 ampere. So I'm explaining this point. I told one question solving is the door to many other questions. Anyone see this picture? They are not saying AC generator in this question. They are not mentioned it is AC generator, but we have to know when a coil is rotating, either it is circle or rectangular or a square loop rotating in a magnetic field, the EMF induced will be NAB omega, the maximum value of EMF NAB omega. Now in this moment, I can say another important point. Suppose we are considering, look, the EMF induced in a rotating rod. This is the EMF induced in a rotating coil. EMF induced in a rotating rod is half BL square omega. So these expressions are very important. This is EMF induced in a rotating rod. This is EMF induced in a rotating coil. Feel the difference and study, feed in memory. Now see here. Yes, right. No, see, that's a question from your side. Sir, whether this type of questions are expecting for the board. You can see last term examination, term 1, they are giving board questions. 2019 also they are giving board questions. So, board questions, that NEET type questions are coming for board as MCQs. As both are conducting by the same board only, the MCQs in the board paper will be in the level of NEET but not in the level of JEE. So we can say this type of questions will be there for our board examination. And now the next one, and one more point, when we are explaining the questions here correctly, that is, the question is not only for in the sense of MCQs, because we have 2 mark and 3 mark questions are also coming, numerical will fall in that. So if they are asking what is the EMF induced in a rotating rod, what is our formula? Don't forget, half BL square omega. What is the EMF induced in a rotating coil? Rotating coil, it is NAB omega. That's the maximum EMF, NAB omega. Now question 6. 2 conducting circular loop of radii R1 and R2 are placed in the same plane with their centers coinciding. R1 greater than R2, what is the mutual inductance between them will be directly proportional to. 2021 NEET question it is, but see, this question is solved in the textbook, and this question came in the board around 8 times for the last 12 years. So different set, if you are checking, you can see that this question is very important. So I'm not directly going to the NEET idea, I'm just explaining how this question we are solving, then we can come back to the NEET shortcut also. So here the question, there is 2 circular loops are given, R1 and R2. R1 is greater than R2 is there. So I'm marking now R2 here and R1 here. So its radius I'm marking, that is R2, and this radius I'm marking, that is R1. So we are assuming current flowing through this outer loop, current flowing through the outer loop. So outer loop as it is marking 1 and inner loop as I'm marking 2. When current flows through the outer loop, there will be a magnetic field linked with the inner loop. So what is the equation for the magnetic field linked with the inner loop? It is at the center of the outer loop. So the field at the center we can consider. So I am ready to calculate the flux linked with the outer loop now, that is phi 2. Flux formula NAB cos theta. So here it is, there is only one loop, so N is not required. Now we can say area of the inner loop, that is A2, and it is in the field of the outer one, that is B1, and then we have a cos theta is there. Now what is A2? A2 means it's circle, so pi R2 square. B1, it is magnetic field due to circle. Magnetic field due to circle is, we can say, at the center mu naught I divided by 2, and it is due to the loop 1, so its radius is R1. Now what is the angle? There, here I marked the area, the current flowing in anti-clockwise. If current flowing anti-clockwise, we know magnetic field is directed outward. We can say if current flows anti-clockwise, magnetic field is directed outward. Area vector also outward. So we can say the field and area vector in the same direction. So it is cos 0. Cos 0 is 1. So I can rewrite mu naught pi R2 square I divided by 2 R1 is the flux linked with the coil 2. Flux linked with the coil has an equation in terms of mutual induction. So what is the formula? Flux linked is equal to Mi. Flux linked phi equal to Mi. So I can write this equation and this one comparing. So I'm getting the formula, that is Mi is equal to mu naught pi R2 square I divided by 2 R1. So you can cancel I and I on both sides. So I'm taking the green color for cancelling. So I and I cancelling. So we are getting the mutual inductance formula, that is mu naught pi R2 square divided by 2R1. So mutual inductance is proportional to R2 square by R1. The right answer is option B. Yes, Adil Farooq, right? And we can say that is some other students are also saying the answer, but it went wrong. No problem. The right answer is option B, R2 square divided by R1. Okay, so this is a question from your side. Sir, if this is coming as an MCQ, then how we will answer this? There is a shortcut for these questions, so that I am explaining here. So you can see here we have two different coils. You know, we derived, for those they studied EMI, they know we derived mutual inductance between two solenoid. When we derived the mutual inductance between two solenoid, we got the idea, that is, we are taking the solenoid wound one over the other. So they have equal area. But if they have a different area, how we can find the mutual inductance? So if they have a different area, to find the mutual inductance, there is a shortcut. You know, mutual inductance is directly proportional to inner area divided by outer length, always. Inner area by outer length. So whether that shortcut is working in this question, we can check. Look, this is the picture now currently here. So we can say here the radius is there. This is we marked as R2 and this we marked as R1. So you will see in the last question we got pi R2 square. So the inner area we have. So inner area pi R2 square. What is the outer length? Outer length means this length, the diameter is coming. So we can say that is 2R1. So this is the picture. If the same one is I'm asking, I think you all are there, you know, see correctly. Now please see, suppose I'm considering a square loop here. A square loop, its length, side length is L. Then I'm taking another square loop inside. Its side length is A. Then what is the mutual inductance between these two coils? The mutual inductance between these two coils is proportional to inner area A square and outer length L will be there. So A square by L. See the shortcut? If the two coils have a different area and different length, we are taking the inner area and outer length we are taking to calculate mutual inductance. This type of questions are there in the paper and also in our board exam. So important question it is. Okay, now we completed mutual inductance question 6 we completed. Now we are doing question 7. Look, two coils are placed close to each other. The mutual inductance of the pair of the coil depends upon. Direct question from NCERT. For those they read our tuition notebook or the textbook, they got the idea. There are 5 factors upon which mutual inductance depends. Which are the 5 factors? So now first one, mutual inductance depends upon nature of the material, or we can say nature of the medium in which the coil placed. And next one, nature of the medium inside the coil. And next one, we can say number of turns of the coil. And the fourth one, we can say that is, the relative position and orientation. Relative position and orientation of the coil. Where these coils are placed, orientation of the coil. So these are the factors. I told 5. If you take position 1 and orientation other, these are the 5 factors upon which mutual inductance depends. So we can say relative position and orientation of the coil is the right answer here, option B. So there is a question from many students side in your mind, sir, why it is no depends on current? There we have the formula phi equal to mi. So when current increases, flux also increases. When current increases, flux also increases. So mutual inductance is independent of current, independent of flux. It is just like capacitance, just like resistance. It is a pure constant, or we can say it depends on the dimension and the position and orientation only. Just like we have one idea that we explained many times in the class, V equal to IR. Whether the resistance depends upon voltage? No. Whether resistance depends upon current? No. Because when voltage increases, current increases. R is a constant. R depends upon 3 things: nature of the material, length and cross-sectional area, and temperature. So we can say these are the points here. Mutual inductance depends on the relative position and orientation of the coil. Yes, the right answer is Adil and Reshma, right? And see, that is another one student is also saying the right answer there. So it's clear that is option B the right question, right option. Now question 7. Now we are trying question 8. Question 8 is based on Lenz's law. So I'm explaining, in order to apply Lenz's law, we have shortcuts. We studied in the classroom. This short time, we are not able to explain all the points based on Lenz's law. But please see, in this question, what is the answer now? A conducting square loop of side L and resistance R moves in its plane with uniform velocity, perpendicular to one of its sides. A magnetic induction B, constant in time and space, pointing perpendicular and into the plane of the loop, exists everywhere as shown in the figure. The current induced in the loop is. So here we can say that, there is the field exists everywhere as shown in the figure now. So this is moving through the magnetic field. We know this is a uniform field. You can see the separation between the cross is same everywhere. So we can say this is a uniform field. We studied how EMF will be induced. The EMF will be induced, when flux changes. We know the formula for flux, E equal to minus d phi by dt. When flux changes only, EMF will be induced. But whether there is any change in flux here? No change in flux, because it is moving through the uniform field. So we said the field is constant and in time and space. So the flux means, flux is BA cos theta. So we can say as it is moving through the field now, there is no change in flux because it is uniform field. So the EMF will be not changing. As a result of flux changing, there is no induced EMF, so it will be 0. Since the change in flux is equal to 0, so the induced EMF will be 0. If induced EMF is 0, we can say the current induced will be also 0. So please see the point what I'm saying. When this loop is moving through the field, they are not saying it is moving out. If it is moving out, what is the option will be there? In field is decreasing. So in field is decreasing means induced current flows in anti-clockwise direction. So anti-clockwise will be there, and the induced EMF will be BLV divided by R. That is the current, I equal to BLV by R. But there is no movement outside the field. It is through the field only moving, so the induced EMF will be definitely coming, that is equal to 0. So that's the question 8th now. So we are going to question 9th. What is question 9th? Look, the magnetic flux linked with the coil is given by the equation. So the flux formula is given 5t square plus 3t plus 16. So they are asking what is the induced EMF. You know the formula for induced EMF, E equal to, already we said, minus d phi by dt is there. So we can say minus d by dt of the flux formula that we have 5t square plus 3t plus 16. So we can say here that is 5t square plus 3t plus 16, we are differentiating. So minus 5t square differentiation. We know differentiation rule for symbol. Multiple the power into coefficient, reduce the power by 1. If there is constant, differentiation is 0. Repeating once more, power into coefficient, reduce the power by 1. So 2 into 5, then t raised to 2 minus 1, t only, and here 3 is there. So we can say that is minus of 10t plus 3 is coming. So we can say here t is given, that is equal to 4. So it is minus 40 plus 3. So the right answer is minus 43 volt. So the right option is coming, that is equal to minus 43 volt. Yes, Nitin, right. Yes, Dhruvil, right. So the right answer is minus 43 volt. But here, please everyone listen, there is an important question. Sir, some questions they are not giving minus sign, then what we have to do? So this is a confusing point for the students. So please listen here. In the case of, in the same question, if there is no option is given with a minus sign, so the question means we have to find the magnitude of induced EMF. So that is equal to plus 43 volt. So solve the problem by giving sign. So in the option no sign is there, means they are meaning it is magnitude of induced EMF. So we are getting that. Why I am saying this means, look, answer is minus 43. All options are positive. So some students are using reasoning ability and they are saying minus 43 is near to very lower value in the option. So that option I will select. No. If there is no negative sign is given, it means that the question is means for magnitude. The question means for magnitude. So we can find the magnitude here, but they are giving minus sign. So we are finding the full EMF, that is minus 43 volt with the magnitude and the direction. Now the next question. An air cord solenoid with length 30 centimeter and cross section 25 centimeter square, number of turns 800, carries a current of 2.5 ampere. The current is suddenly switched off in a brief time, 10 raised to minus 3 seconds. Ignoring the variation in magnetic field near the ends of the solenoid, the average back EMF induced across the ends of the open switch in the circuit would be. So we want to find the back EMF induced. What are the datas given? Look, length given 30 centimeter. So I'm trying, that is 30 into 10 raised to minus 2 meter. Area of cross section is given. So area 25 centimeter square. So 25 into 10 raised to minus 4 meter square. And the number of turns given, see on the online students, you can just try with me and give me the answer in the chat box. Now 800 carries a current, so I is given 2.5 ampere. Ignoring the variation of magnetic field, they are asking what is the average back EMF induced. So how I will find from this data the induced EMF? It's a lengthy procedure. Please see. We know the EMF equation, that is equal to minus d phi by dt. And here the current, the initial current is 2.5. It's switched off, they said. So the final current will be 0 ampere. So now E equal to minus d phi by dt. So I want to find the induced EMF. The back EMF means induced EMF. So how we can find the induced EMF? So minus d by dt of the flux means I can write NAB. And here the angle is not given, so we can say that correctly the coil variation of the magnetic field length of the solenoid we are neglecting, and air cord solenoid is there, so we can say that the angle will be here 0 coming. So NAB. Here number of turns is not changing, so I can take that is N, and area is not changing, and then we have a dB by dt is there. But magnetic field is not changing. Magnetic field due to the solenoid, that is mu naught Ni. So we can say, yes, right. Okay. So we can find a dB by dt value. So that is minus Na into d by dt of, the field due to the solenoid, mu naught Ni. But see this small n we can replace. Small n is capital N by L. So I can write that is minus Na. Then here mu naught is not changing, it's clear. And small n is not changing, it's clear. But di by dt is there, di by dt. So this small n we can replace. So we are getting the formula that is equal to, so please see, we are getting the formula that is the induced EMF is equal to minus n. Please see the formula. This small n I am writing capital N by L. So we can say capital N by L. Then here the terms are remaining. A mu naught di by dt is there. So I can write A mu naught di over dt. So I can write minus n square A mu naught di by dt by L is there, by L. So you can substitute all the values. All the values are in SI unit. So substitute them and you will get the EMF. I'm saying the right answer here in this option now. That is 6.54 volt is the right answer you are getting. By substituting you will get that is minus. Why there is no minus now? 6.54 volt only there, because di is there, see in this question di, it's switched off, we can say correctly, that is a brief time 10 raised to minus 3 second. So the time interval is given 0.3 second, and the change in current will be 0 minus 2.5. So 0 minus 2.5 means minus 2.5. That minus and this minus will be cancelling. So 0 minus 2.5. So that is minus 2.5 is there. So simplifying, you will get the answer 6.54 volt is there. I'm saying our live sessions are not aiming only MCQs. MCQs based conceptual questions, expecting 2 and 3 mark in the board. So now the next question we are explaining. So look, question 11th. If both the number of turns and the core length of an inductor is doubled, keeping the other factors constant, how the self-inductance will be? Direct application question. I think you can answer now. That is, self-inductance is equal to mu naught n square A over L. That's the formula for self-inductance. So we can say here number of turns and length are doubled. So the new self-inductance will be mu naught, number of turns doubled, 2n square A, and length is also doubled. So here it is very clear. You can see that this 2 square is there. So I can write that is 2 square is 4. And then divided by 2, then all other terms are L. So 4 by 2 is 2. So that is equal to 2L. So we can say it is doubled. So the right answer, option B, we can say question 11th, option B, it is doubled. Now we are trying the next question. Question 12. A circular loop of radius 0.3 centimeter lies parallel to much bigger circular of radius 20 centimeter. The center of the small loop is on the axis of the bigger loop. The distance between their center is 15 centimeter. If a current 2 ampere flows through the smaller loop, then the flux linked with the bigger loop is. See, question important one. I'm explaining. Please see. Look, there is 2 circular loops. That is one circular loop like this, and we can say parallel another circular loop. So on the same axis of the bigger loop. So another big circular loop is there. 2 circular loop. They have common axis. So marking their axis will be common axis, and the radius of the smaller one given 0.3 centimeter. So this radius 0.3 into 10 raised to minus 2 meter lies parallel, and we can say its radius is given, that is equal to 20 centimeter. Radius 20 centimeter. And the next point, they are separated by 15 centimeter. So the separation given 15 centimeter. 15 centimeter. Now, if a current 2 ampere flows through the smaller loop, so current flowing through the smaller loop is 2 ampere. Then what is the flux linked with the bigger loop? So the point I am explaining, the current is flowing through the smaller loop. What is the flux linked with the bigger loop? That's the question there. So we can say correctly, that is how we can find the flux linked with the bigger loop. In order to find that, first we are considering this formula, that is the magnetic flux is equal to, the flux linked with, marking this is a second loop, okay? The flux linked with the second loop is equal to, we can say, the mutual inductance into I1. Because we know flux is equal to Mi. So as it is mutual inductance, flux linked with the second loop is mutual inductance into I1. So in the case of flux, what I will calculate, flux linked with the second loop is equal to Mi1 is there. What is the flux linked with the second loop now? I can say that is we have to find the flux linked with the bigger loop here. Phi is equal to Mi1 is there. So we can substitute the values for flux. Flux is equal to BA. So I can write that is equal to B2 into A1. Why B2 into A1 here? The current flowing through this loop. So the area linked with the second loop in the field is this much only. this much area will be there linked with the inner loop. So that is equal to Mi1 is there. So we are getting the formula, substituting the datas, 9.1 into 10 raised to minus 11 Weber is there. As we have many questions, I am going to do the next question now. Please see, look. When the current changes from plus 2 ampere to minus 2 ampere in 0.05 second, an EMF of 8 volt is induced in the coil. The coefficient of self-inductance of the coil. So we have the formula E is equal to minus L di by dt is there. So EMF is given, that is equal to 8, and L value is we have to find, okay, minus L. Di is there. I'm going little faster because we have only 5 minutes. Okay, Di is there. Di is the change in current. So 2 ampere to minus 2 ampere. So final is minus 2, then minus 2 divided by the time is given in this question, that is equal to the time is given 0.05 second is there, and we can substitute the values correctly and you will get the minus. So it's coming L into 4 divided by 0.05 is 8. So we can say L is equal to 8 into 0.05 divided by 4. So simplifying, 2 into 0.05 is there. So right answer is 0.1 Henry. Right answer option D. Now the next question, question 14. Question 14 is also confusing question. Please see, look. Two similar circular loops carry equal current in the same direction. On moving the coil farther apart, what happened to the electric current? So we can say two loop, they are flowing, the current will be in the same direction. So we can say like this, if here it is clockwise, anti-clockwise, here also anti-clockwise will be there. Both loop current will be in anti-clockwise. Now when they are moving farther apart, what happened? You know, according to Lenz's law, we can say that the induced current opposes the cause to produce change in flux. So when they are moving apart, listen here, when these two coils are moving apart, we can say the field linked with the coil or the flux linked with the coil decreases. But the induced EMF opposes that decrease in flux. So the induced current will be in such a manner that it will increase the current in the circuit. So the right option A increases in both. So option A the right one. Now the next question. Look, a square loop of side 25 centimeter having 1000 turns is rotated with a uniform speed in a magnetic field about an axis perpendicular to the direction of the field. At an instant, the EMF induced in the coil is 200 sin 100 pi t, the magnetic induction. See, I am explaining. Look, the question here, square coil rotate. So as I said before, which formula? The induced EMF equation, NAB omega we are using. And then the problem here, omega is not given and the maximum EMF is not given, but they are given in this equation. What is the maximum EMF? That is 200. And N value is given, that is 1000. Area is given in the question, square coil. So 25 into 10 raised to minus 2 whole square. Look, magnetic field is we have to find, so magnetic induction. Then where omega is there, you know, omega is equal to 100 pi. So it's given 100 pi is omega, because we know what is the equation for induced EMF we studied, that is equal to E equal to NAB omega sin omega t. So it's clear. NAB omega directly given 200. So you can find the B value from this directly. The answer is coming 0.01 T is their correct. Option D the right answer, 0.01 T. Okay. Now the next question. Question 16. Very important. Look, the variation of induced EMF with the time in a coil. Look, I'm saying very important question it is. Look, moved along its axis with a constant velocity is best represented by. So listen, this question is coming like that, either this way or this way the question is coming. So coil is here and the magnet is here and it is falling like this, or it is moving horizontally. See the difference. When it is moving into the coil, the flux will increase. Flux increase means d phi by dt will be positive. But the induced EMF equation is minus d phi by dt. So see, d phi by dt positive, but it is minus d phi by dt. So we can say correctly, there is a minus sign. So that graph starts with the minus sign. Graph starts with a minus sign, and then as it is going away, we can say flux decreases. Look, when it is passing through this, if the loop reaches here and going away, flux decreases. Flux decreases means EMF will be positive, because d phi by dt will be, we can say, negative. Minus into minus becomes a positive. So the right answer is option B. We can say that is minus d phi by dt. Right. I'm saying the last point today. Please see, don't forget, after 20 days we have. So what I'm saying, if it is moving like this, what is the picture there? If it is moving like this, so we can say, if it is moving like this, the graph will be same manner, but there is a difference. The lower peak will be more than upper peak. Please take care. Why the lower peak is more than upper peak? The reason is that when it is falling, according to Lenz's law, the induced current opposes its motion. So we can say acceleration will be decreasing, speed will be decreasing, motional EMF is BVL. So we can say here the picture, if we are considering this picture, lower end will be more than the upper end correctly. So this point, horizontal no difference in amplitude, but vertical there is the difference in amplitude is there. So that's the point, question 16. Now look, question 17 is there. The answer I am marking, that is 3 MV. And then question 18 is there. The answer I am saying 4.8 into 10 raised to minus 2 volt. And next one, the answer is there, dNAB omega. So we explained all the important points of this chapter, electromagnetic induction. Please go through that. It will definitely help you in the board examination. Watch the video again and again and subscribe. Thank you. I'm Muhammad Shamim signing off. Thank you.
IIT, JE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.